Module 1, Topic 3, entitled Data Models. This topic examines data modeling. Data modeling is the first step in the database design journey, serving as a bridge between a real-world object and the computer database. You will learn first some basic data modeling concepts and how current data models have developed from earlier models.
Learning objectives. At the end of this lesson, the students are expected to discuss data modeling and why data models are important, describe the basic data modeling building blocks, define what business rules are and how they influence database design, understand how the major data models evolve, list emerging alternative data models and the needs they fulfill, and explain how data models can be classified by their model of abstraction.
Database design focuses on how the database structure will be used to store and manage end-user data. Data modeling, the first step in designing a database, refers to the process of creating a specific data model for a determined problem domain. A data model is a relatively simple representation, usually graphical, of more complex real-world data structures. In general terms, a model is an abstraction of a more complex real-world object or event. A model's main function is to help you understand the complexities of the real-world environment. Within the database environment, a data model represents data structures and their characteristics, relations, constraints, transformations, and other constructs with the purpose of supporting a specific problem domain. The importance of data modeling cannot be overstated. It facilitates communication. Data models can facilitate interaction among the designer, the application's programmer, and the end user. Data models are a communication tool. Data modeling gives various views of the database. Data constitutes the most basic information employed by a system. Applications are created to manage data and to help transform data into information, but data is viewed in different ways by different people. Data modeling organizes data for various users. When a good database blueprint is available, it doesn't matter that an application programmer's view of the data is different from that of the manager or the end user. Provides an abstraction for the creation of a good database. The data model is an abstraction. You cannot draw the required data out of the data model. The basic building blocks of all data models are entities, attributes, relationships, and constraints. An entity is a person, place, thing, or event about which data will be collected and stored. An entity represents a particular type of object in the real world, which means an entity is distinguishable. That is, each entity occurrence is unique and distinct. An attribute is a characteristic of an entity. A relationship describes an association among entities. For example, a relationship exists between customers and agents that can be described as follows. An agent can serve many customers, and each customer may be served by one agent. Data models use three types of relationships: one-to-many, many-to-many, and one-to-one. Database designers usually use the shorthand notations 1:m or 1 to asterisk, m:n or asterisk to asterisk, and 1:1 or 1-to-1 respectively. A constraint is a restriction placed on the data. Constraints are important because they help to ensure data integrity. Constraints are normally expressed in the form of rules. From a database point of view, the collection of data becomes meaningful only when it reflects properly defined business rules. A business rule is a brief, precise, and unambiguous description of a policy, procedure, or principle within a specific organization. Business rules derive from a detailed description of an organization's operations, help to create and enforce actions within that organization's environment. Properly written business rules are used to define entities, attributes, relationships, and constraints. The main sources of business rules are company managers, policymakers, department managers, and written documentation such as a company's procedure, standards, and operations manuals. A faster and more direct source of business rules is direct interviews with end users. The process of identifying and documenting business rules is essential to database design for several reasons. It helps to standardize the company's view of data. It can be a communication tool between users and designers. It allows the designer to understand the nature, role, and scope of the data. It allows the designer to understand business processes. It allows the designer also to develop appropriate relationship participation rules and constraints and to create an accurate data model. Business rules set the stage for the proper identification of entities, attributes, relationships, and constraints. In the real world, names are used to identify objects. As a general rule, a noun in the business rule will translate into an entity in the model, and a verb that associates the nouns will translate into a relationship among the entities. For example, the business rule, "a customer may generate many invoices," contains two nouns, customer and invoices, and a verb, generate, that associates the nouns. From this business rule, you could deduce the following. Customer and invoice are objects of interest for the environment and should be represented by their respective entities. There is a generate relationship between customer and invoice. To properly identify the type of relationship, you should consider that relationships are bidirectional. That is, they go both ways. For example, the business rule, "a customer may generate many invoices," is complemented by the business rule, "an invoice is generated by only one customer." In that case, the relationship is one-to-many, and customer is the one side and the invoice is the many side. To properly identify the relationship type, you should generally ask two questions. How many instances of B are related to one instance of A? How many instances of A are related to one instance of B? For example, you can assess the relationship between student and class by asking two questions. In how many classes can one student enroll? The answer, many classes. How many students can enroll in one class? Answer, many students. During the translation of business rules to data model components, you identify entities, attributes, relationships, and constraints. This identification process includes naming the object in a way that makes it unique and distinguishable from other objects in the problem domain. It is important to pay special attention to how you name the objects you are discovering. Entity names should be descriptive of the objects in the business environment and use terminology that is familiar to the users. An attribute name should also be descriptive of the data represented by that attribute. It is also a good practice to prefix the name of an attribute with the name or abbreviation of the entity in which it occurs. The use of a proper naming convention will improve the data model's ability to facilitate communication among the designer, application programmer, and the end user. A proper naming convention can go along towards making your model self-documenting. The evolution of data models is the quest for better data management led to several models that attempt to resolve the previous model's critical shortcomings and to provide solutions to ever-evolving data management needs. The hierarchical model was developed in the 1960s to manage large amounts of data for complex manufacturing projects, such as the Apollo rocket that landed on the moon in 1969. The model's basic logical structure is represented by an upside-down tree. The hierarchical structure contains levels or segments. A segment is the equivalent of a file system's record type. Within the hierarchy, a higher layer is perceived as the parent of the segment directly beneath it, which is called the child. The hierarchical model depicts a set of one-to-many relationships between a parent and its children segments. Each parent can have many children, but each child has only one parent. The network model was created to represent complex data relationships more effectively than the hierarchical model, to improve database performance, and to impose a database standard. In the network model, the user perceives the network database as a collection of records in one-to-many relationships. However, unlike the hierarchical model, the network model allows a record to have more than one parent. While the network database model is generally not used today, the definitions of standard database concepts that emerge with the network model are still used by the modern data models. The schema is the conceptual organization of the entire database as viewed by the database administrator. The subschema defines the portion of the database seen by the application programs that actually produce the desired information from the data within the database. A data manipulation language, or DML, defines the environment in which data can be managed and is used to work with the data in the database. A schema data definition language enables the database administrator to define the schema components. The relational model's foundation is a mathematical concept known as a relation. To avoid the complexity of abstract mathematical theory, you can think of a relation, sometimes called a table, as a two-dimensional structure composed of intersecting rows and columns. Each row in a relation is called a tuple. Each column represents an attribute. The relational model also describes a precise set of data manipulation constructs based on advanced mathematical concepts. The relational data model is implemented through a very sophisticated relational database management system, or RDBMS. This performs the same basic functions provided by the hierarchical and network DBMS systems, in addition to a host of other functions that make the relational data model easier to understand and implement. The most important advantage of the RDBMS is its ability to hide the complexities of the relational model from the user. The RDBMS manages all of the physical details, while the user sees the relational database as a collection of tables in which data is stored. The user can manipulate and query the data in a way that seems intuitive and logical. Figure 2.2 displays the relational diagram that shows the connecting fields, agent code, and the relationship type one-to-many. Microsoft Access, the database software application used to generate this, employs the infinity symbol to indicate the many side. In this example, the customer represents the many side because an agent can have many customers. The agent represents the one side because each customer has only one agent. A relational table stores a collection of related entities. In this respect, the relational database table resembles a file, but there is a crucial difference between a table and a file. A table yields complete data and structural independence because it is a purely logical structure. How the data is physically stored in the database is of no concern to the user or the designer. The perception is what counts. Another reason for the relational data model's rise to dominance is its powerful and flexible query language. Most relational database software uses structured query language, or SQL, which allows the user to specify what must be done without specifying how. The RDBMS uses SQL to translate user queries into instructions for retrieving the requested data. SQL makes it possible to retrieve data with far less effort than any other database or file environment. From an end-user perspective, any SQL-based relational database application involves three parts: a user interface, a set of tables stored in the database, and the SQL engine. The next slide on this topic 3, data models, is about the entity relationship model.